So I'm back. It's been a little while, and luckily, I was working on a really good contract. So yeah, I was pretty much busy for about a year. All right, so getting back into the videos, there's a few things I'm going to do which are going to be different to how I did things before. So number one, I'm going to try and not waffle too much because I tend to do that. I'm not like the best kind of speaker. So I talk a lot of crap sometimes, so I want to minimize on that. Um, and then, yeah, so pretty much get straight to the point, and try and not make my videos too long because it's much better when you've got a short video and everything is kind of like really straight to the point and condensed, and you can very quickly get through the point of the video, right? So that's my other aim. What else was there? Can't remember. All right. So, in saying that, I'm going to get straight into it. And the video which I'm going to do today is a popular requested video, which is how to run a cluster. So, previously, I've been trying to show you how to do a standalone, or not try, I have been showing you how to do a standalone. But now, what we're going to do, we're going to do um, simultaneous computation across nodes, and typically you would do that on AWS cluster, but I don't have the money to run AWS, but I can show you on some Raspberry Pis, and I have set up Raspberry Pis before, and you can go to my video and see these videos in pink. So the first one, I set up a Raspberry Pi cluster, so that's like physically stacking them together, and it's a lot better to stack them together neatly than to have them sort of separated. And then the next video after that shows you how to format an SD card, and then the one above that is creating your boot disk. So you download an operating system which is compatible for the RPI Raspberry Pi, and then you can create your operating system, your boot disk. And the one that I used is Kali Linux, and I find that Kali Linux is pretty works pretty good because it doesn't go down. It's got a lot of daemons running in running in the background, so it kind of stays alive. When you use other ones like maybe Ubuntu or Raspberry Pi OS, the Raspberry Pi tends to kind of stop working. You've got to connect the HDMI back into it, fire it back up. But Kali Linux doesn't really have that problem so much. And then the next one, which is the more important one, once you get your stack or cluster bunch of nodes running using our Raspberry Pis, then you need to SSH into them. So I've shown you how to do that in this particular video, my last one, for the RPI cluster. And you're connecting this computer to your nodes. So this computer is called the master, and you're connecting them to your workers, and your workers are each of those Raspberry Pis devices that you have, which are called the nodes or node worker. And I've already set mine up, and to keep things quick, I will not go through absolutely everything. I will set up the master, and you're going to repeat the same thing on the master on each of the nodes. So in previous videos, I've also shown you how to set up the set up Spark, configure Spark, set that up, and yeah, so you've got that running on your master. You're going to do the same thing, the same way you set up Spark on your master. You're going to set it up on each of those nodes. And then yeah, so once you've done that, then we can progress. So I've just got, I'll just move this out of the way for a sec. So I've got this in front of me, and here you can see the settings for the nodes. So if you haven't done already, what you need to do, you'll need to connect your master to itself. So that's the first one. So I'll just quickly explain what's going on here. So I've got nodes, I've got cluster, and I've got worker. So this cluster, this is going to be the content of your cluster file, and I'll get that back to you, or how can I say that? Not cluster, the Spark environment file, but I've just called that cluster. And then you've got a worker file. So let's just call that something different. Spark.env.sh. It's going to be that particular file. And then you've got another file called worker. And then these are the configurations for my nodes. So I'll just explain this. So this is my master, so that's my IP for my master, and this is my local of my master. So I still need to SSH locally, and that's why I've got this command, and I'll tell you what this command does. I also need to SSH remote connect to each of my clusters, and I'm running 3 clusters. So these are the IP addresses for my 3 clusters. And in order to passwordless connect, then I just need to run these commands. So I need to run a command to passwordless connect locally to my same machine. Then I need to passwordless connect to each of my Raspberry Pi nodes. Now I showed you how to do that previously in this particular video, and that's exactly what we're doing here. So I need to run that, cd into that. I need to run that into my machine, the machine that I'm currently using. So all of these commands. So I've already done that. So you're just going to pretty much do this. Just copy it. Or I'll type one out to begin with. So cat, and I'll explain what each of them do. Alright, so this particular command, what we're doing, we are copying the contents of our public key, RSA key, and we are connecting locally and copying it into the authorized keys locally. That's what we're doing for the first one. So I can just press enter on that. Now I've done this already, but if you haven't done this before, you'll see something say agree to fingerprint, and then yes or no, and you just type yes, and then it will then ask you for the password, and then you put in the password. So because this is the local one, it will be my local password. Now the next one is going to differ slightly, so it's going to be, instead of localhost, it will be the IP address. So my first IP address for one of my nodes, Raspberry Pi nodes, I'm just going to put that in there. And I'm pretty much doing the exact same thing, and it's yeah, no errors. It's allowed me to do it. I've done it before, so that's why it's not coming up with a confirm fingerprint, yes no option, then press, then put in password, because I've actually done this before and connected my Raspberry Pis. Alright, then I'm going to do the same thing for my next node, and then my next node. And if you've got more nodes, then you'll just put that in, and that way you can get that passwordless connection. And then what you need to do, you need to log in to each of your Raspberry Pis, and you need to connect, or you need to add the keys in the opposite direction. So for my Raspberry Pi node, let's say R06, I need to add my master IP into the authorized keys. So I'm already connected. So here you've got R06, R08, R10. Now what the R08, R10 and R06 mean, that's just my unique host name. So I've given it a unique host name, and I think, again, in this video, I've actually, I think I've actually given instruction on how to do that. I hope I have. Yeah, so if you're using a host name, unique host name, then it's just a lot easier to know, to seamlessly communicate with the particular node which you need to communicate with, and get information and so forth. Okay, so I'm logged in, and I'll just log out and I'll just show you how I log in. So let's just exit. There's a bit of latency on this, so to log in it is pretty much just SSH username, then R06. So here I'm not using the IP address, I'm just using the R06. So I'm not using the IP address, I'm just using the username R06. So here, that's a good example of making it easy to log in without the password as well. Okay, so the next step, what is the next step? I've just got a few more windows open here. So the next step I need to do is I need to set the paths. Now I think I've done this already, so let's just go into my bashrc. So in my bashrc, I need to set a directory location in my paths, which is sbin. So I've done that already, and going back to how I set up Spark before, I showed you, I went through this step on setting your paths, and I don't think in the previous videos I had set a path for sbin. So here I'm just copying this particular line, and just adding the additional directory, which is sbin. So sbin, if I just go into that, just get that path here. So so sbin is this particular directory, and if I just go into that directory, then you'll see a load of bash files. So these bash files allow you to manage the server, the cluster, or the server, and you can start. There's quite a good few bash scripts in there to help you do stuff. So instead of setting the full path for that, by setting my paths here, then I can just run, for example, I could just run start all.sh just to make things easier. So the same way we did, start shell. So start shell is in this, it's an application inside your bin directory, and if I were to do that, it says, sorry, not start shell, spark shell. If I were to do that, then it would fire up the Spark shell. Now in firing this up, I just want to quickly show you something else. The web UI is going to be located here. So, you know, look for that. That's a very useful address when you need to access the web UI. And I'll just come out of that for a quick sec. All right, so the next thing I want to do, I want to, and let's just quickly, because I'm just going to do this over again. So I'm just going to quickly delete some files which I've already created. So home, and I'll just create them again. Alright, so and the other one I want to get rid of is going to be spark.env.sh. So these two files I just want to create from scratch. And let's just go into this directory. Alright, so oh, it's still there. Okay, let's make sure we delete that. Right, so refresh this one. Okay, we're going to start from absolute scratch here. So, right, I want to create two files. So I want to copy this file, spark-env.sh template, and also workers template. So let's copy those. So we'll copy the spark-env.sh one first. And we're going to do a sudo copy, and we're going to rename that, or copy it, not rename, we're going to copy it without the template. So that's the file that we need. And the next file is going to be workers template, so we'll throw that in there as well. And what you're seeing me do is I'm just dragging and dropping the file into my terminal, and that's how I just get the full address without having to type the whole thing out. And we'll call that template, and we'll just do a sudo cp, and that's copied. And now I can go over to here, and we can see it. So we've got spark.sh, and we're just gonna spark environment .sh, and let's just go to the bottom of that file, and we're going to copy some information in there. So I'm just going to copy this info, and I'll just explain what it is. And I'm copying it just so that I don't take too long typing it out and typing errors. Alright, so here we've got Spark master, so we need to specify the master. We've got Spark log directory, and we've got Spark work directory. So we need to create two directories, one for our logs and one for our work. And I'm setting custom locations for that. And then the IP address, this IP address is going to be this particular machine. Now to find your IP address, all you need to do is just do a if config, press enter, and then you'll see IP addresses. So you could have an IP address for, sorry, you will have an IP address for Ethernet, which is your wired connection, and if you're using Wi-Fi, then you'll see one also for your Wi-Fi. If you get an error message, or not an error message, if you get a message saying you don't have ifconfig installed, then you can install it with a sudo apt install net tools. So I've already got that installed, which says it's already the newest version, and then that will give you the ability to use ifconfig, and that's really good for just seeing what your IP addresses are. So once you see your IP address, you can then put it in here. So that's going to be your master one, this machine that I'm using, and then you need to create this particular directory. So I've called that cluster, and that sits in my project directory. So the project directory which I created and put it up onto GitHub, inside of that you're going to create a directory for your cluster, or it could be anywhere in your machine, but then you just specify exactly where it is, and then logs will get created, and then your work directory will also get created as well automatically. But you need to create this particular one, cluster. You call it whatever you like. It could be, logs doesn't have to be in cluster. It can just be logs here within your project directory. So for example, you could just put logs here, right? But I'm not doing that. I like to be very specific on where I'm putting things. All right, so within your nodes, so the other thing that I need to mention is the whole ifconfig thing, right? It's best to use an Ethernet connection for your IP. I've not got my Raspberry Pis connected by Ethernet, a wired connection. I'm using Wi-Fi. Not ideal, because the data is going to be, the transfer of data is going to be like a bottleneck, right, going across Wi-Fi. So you really want to do it by a Ethernet connected. So connect your Raspberry Pis into your router. But for testing purposes and setting up purposes and showing you how to create a cluster, I'm just going to use Wi-Fi. In practice, I don't really do things across a cluster because I don't really need to. And most people don't. So when you set up a cluster, typically you'll get the computational power setting it up on a cloud like AWS using EMR, but because I don't have the money for that, then I'm not doing that. I just really do it standalone, but I'm showing you how to do it, how to set up a cluster. And if you need to test a cluster locally using things like Raspberry Pis or other computers, for example, with more power, then this is how you can do it. All right. Alright, so what do I need to do next? So the next thing I need to do is I need to set up my worker. Okay, so let's go over to here and go to workers, and I need to add my Raspberry Pis. So let's just take a look at what I'm going to add. So here's the worker. We've already got localhost. So I'm going to add these three host names: R06, R08, R10. So what that corresponds to, R06 is the host name I've given to my Raspberry Pi, which is located at this address, and then R08 for this address, R10 for this address. So that way I can be a lot cleaner and just specify host names rather than IP addresses. And then yeah, so the next thing I need to do, I am going to map those those IP addresses to the host names in my host files. So I'm going to go to sudo vim etc hosts. So it knows exactly where it's communicating to. So if I just grab one of those, so the first one is going to be that, and that's going to be R06. The next one is going to be that, and that's going to be R08, I think. Yep, 8, and then the next one is going to be that, R10. Okay, now I can save that. So, you know, locally within my master, being this machine which I'm working on, you know, if I specify R08, R010, it knows exactly which, you know, where it's located on the network, because I've mapped it in my etc host file. All right. So the next thing we need to do, and I think I've already mentioned it, but let's just go back here. So I'm already logged into R06, right? Now, what we need to do, exactly the same settings that I have, the same way I've configured Spark locally, you know, on this machine, I need to do that on each of my Raspberry Pi devices. So the same installation of Spark, what I just did here, where I created these files, spark environment.sh and workers, I need to do the same thing locally, remotely on each of those devices as well. Exactly what I've just done here locally, you need to do the same thing on your nodes, your Raspberry Pi worker nodes. So if I just go into that, you can see that I've already done it. Let's change. Actually, let's try this one, because I know I'm having latency issues with that particular one. So I'm already in that directory. So let's just list it. So I've already done it. So the exact same configuration. So let's take a look at this one. So exactly what I did here, I've done that on my Raspberry Pi node here. So the Spark master is going to be the IP address for this machine, which I'm currently on. Yeah, this particular machine, which I'm currently on. Because it needs to communicate, it needs to know which one is the master. So we're going back and forth. And then for each of these workers, so I'm also providing the same settings. So it knows R06, R08, R10. Those are the listed workers, nodes. So exact same settings. All right. So I'm able to SSH passwordless into each of those nodes, and if you can connect passwordless to each of those worker nodes, then you know Spark is gonna be able to just connect and do what it needs to do without any issues. All right. Okay, so let's now start a cluster. So because I've set my path to the sbin in my bashrc, I can now just type start all.sh. Okay, good, no errors. If you see any errors, then you've got connection issues. If you get any connection issues, just type a comment and then I will help you troubleshoot. Yeah, I know I haven't responded to some of the comments before, but I promise I will on this particular one. All right, so so here we can see my master is connected, is running as localhost here, and R06, which is the host name for one of my Raspberry Pis, is running, and that's the process. and also for R10 and R8. So you can stop the cluster by doing a stop all, and it will stop, stopping everything, but I'll start it back up again. Okay, let that start up again. Alright, so let me just go back to, let's go back to this. So first of all, I'm just going to stop that one more time. I'm going to do a Spark shell one more time, because I just want to copy and paste the web UI address, and I'll just get a browser window over here as well. So this is the address which I am going to go to. So let's just put that in there. So as you can see, we get a UI page for Spark jobs, but it's not actually port 4040 which we're going to access. But I just wanted to copy and paste this bit here up until just before where we specify port, and I can just stop that shell, and I can go back to my cluster, start my cluster, and then I can type in, instead of 4040, it's going to be 8080. And did that work? No, it didn't. Oh, okay, because I didn't start it. Let's start it. Alright, so I am now at 8080. Great, it's working. Alright, so let's run an application. So okay, I just did a refresh there because I was wondering, I couldn't see the other workers. So here we've got 59. This is my, it says worker, but you know, it is my master. So my master 59, and there's also a worker here for that particular IP, which is 59. This is the machine which I'm on. And then you've also got 67, 70 and 86. So these are my Raspberry Pi nodes, and if you can see it in the UI, then you know it's running, it's all good. Alright, so let's run a job across the cluster. So what I'm going to do, I'm going to go into this folder. And I am going to go into examples. CD into src and CD into main, and then CD into Python. I think it's Python. Let me check. Yeah, so yeah, okay, all right. Let me, yeah, sorry. Let me. I'll just continue going. So CD Python, and then so this is the script we're going to run. So this is an example script that comes with Spark. So if I just do a cat, we can see it's just a very simple script, and we're going to run that across the cluster. All right, so I'm just going to go back into this directory. All right, just clear that, and I'm going to say Spark. This is very, very simple and basic. So Spark submit master. So my master is going to be this address. Just copy that. And then I am going to run examples src main python pi.py. I could just also do the full address for that. It doesn't really matter, you know. I could just do a spark submit where the master is, and then the full path for that particular file. I mean, because you could have a job anywhere on your machine, right? So yeah, so don't pay too much attention to me going into this directory and then doing a relative path to here. Don't pay attention to that at all. Just put in a full path if you need to. And let's just run that. Okay, something is not recognized, so what did I do wrong? Okay, so I forgot to put in master, so master. Okay, that's now running. Allow that to run. And it's complete. Okay, so let's go back to our UI, just refresh that. And as you can see here, we've got that job that ran Python Py, named Python Py. You can go into the application and you can see it was run across all of these workers, and each of these have 4 cores. My worker one, sorry, my master one, my machine, which is also a worker, which I'm using, has 8 cores, and then Raspberry Pis, I'm using Raspberry Pi version 4, and the new version 4 each have 4 cores. So that's a good considerable amount of power. It's only a simple job, you know. If you're really running loads and loads of data, you're not going to do it over Wi-Fi. You're going to do it using a connected wired connection using Ethernet. So yeah, just running a simple job, I was able to do that over Wi-Fi across all of those workers, and yeah, it's good. And here's the result. Pi is roughly 3.149280. That's the result. So yeah, so that is showing you how to run a cluster. So you can go into each of these and you can get a little bit more information. Here's a log, stand it out. If you had errors, it will show you what the errors are. And yeah, so all of your information in your UI. And I think that's it. So I just wanted to make a very quick, short video on how to do that. And yeah, I think that concludes it for the moment. And I hope you can follow this. I rather give you every step, right? Type everything out so you can follow exactly what I did. You can still do that. The only thing that I didn't do is exactly what I did here on my master. I didn't, verbose show you exactly how I did it here, but it is very much the exact same thing. So yeah, any problems on setting up a cluster or connecting, then just go back to these tutorials on how to set up a Raspberry cluster. If you're using Raspberry Pis, you don't need to use Raspberry Pis. You can do that using virtual machines, or if you've got additional laptops, you can, exactly as I did it on Raspberry Pi, you can do it on your additional laptops. So you've got that choice. And that just saves you spending money on a cloud somewhere. And if you're testing, getting familiar with Spark, then I recommend you do it on local machines. Attach devices to your network. yeah, don't spend any money. Try to avoid spending money. You can do all of this without spending money and wasting money. So yeah, um, cheers, and I'll catch you in the next one later on. All right, so I thought I'll just add a bit more to this video. So I was in the middle of just about to upload it, and I thought, okay, there's definitely going to be an error that you're going to run into, and I need to let you know how you get around that issue. So it's going to be something to do with memory, the amount of RAM which is available to you. So it's quite likely that the error will look something like this. And then you're going to scratch your head and say, okay, how do I get around that? What's going on? So you just need to make an adjustment in your settings, and and there is a particular file for that, and it's called spark-defaults.conf. And you make a copy of that file from this particular file, which ends with template, exactly as you did with workers from this template file, and Spark environment from this template file. So you just make a copy of that, and if I go into that file, then you're going to get a template, and it's this particular line here, which is Spark driver memory, and you can set a custom configuration for that. So you just uncomment that line, and then you can just sort of boost that up. So whatever amount of RAM that you have available, you can assign a proportion of that. So you can assign it like 32, if you've got that amount of RAM available, 16, etc. All right, so let's just come out of that, and I'm going to go into my one. So here you can see I've got that set up as Spark driver memory 15 gig, so that gives me enough memory to run large jobs. So yeah, I thought I'd better point that one out, because you will run into that if you try and run jobs which require a lot of RAM, a lot of memory, and then you'll want to know how you get around that. All right, cheers, bye.